Hello and welcome to this session. My name is Shian Nafti. I'm a Google authorized trainer. I travel around the world delivering training to Google's clients and partners. In today's session, we're going to explore Anthos GKE Connect and Anthos Service Mesh. Anthos GKE Connect enables us to register remote clusters on the Google Cloud Platform and manage those clusters through a single pane of glass. Anthos Service Mesh enables us to embrace SRE best practices as we operate and manage our enterprise workloads. Let's get started by installing the tools we're going to use throughout the demo. The first tool we're going to install is kubectx. kubectx enables us to more easily switch context between Kubernetes clusters. Next, we're going to install kops. Kops is a utility developed by the Kubernetes community that enables us to more easily configure a remote Kubernetes cluster using virtual machines. We're going to use kops to create a Kubernetes cluster on Compute Engine instances on the Google Cloud Platform. And finally, we're going to download and extract Istio. The version of Istio we're going to use in this demo is version 1.3.2. Proceed to the next step where we're going to enable access to the services we're going to use on the Google Cloud Platform. We're going to do this by activating the APIs that enable us to interact with these services. Having enabled the APIs, we're now in a position to create a Kubernetes cluster. Let's go ahead and create a Kubernetes cluster in the US Central 1 region. The Kubernetes cluster will be a 2-node cluster with auto-scaling enabled, allowing us to scale to up to a maximum of 4 nodes. You can also see here that we're using a specific version of Kubernetes. This is important because Anthos Service Mesh supports a subset of Kubernetes versions. Additionally, there is a requirement for us to enable workload identities as well as assign a label to our Kubernetes cluster. Let's carry on and create this cluster. With the cluster created, we're going to retrieve its credentials. Having retrieved its credentials, we're going to switch context to the cluster. We're going to save the configuration for the cluster in the file central.context. Next, we're going to grant admin privileges to the current logged in user. Before moving on to the next step, let's explore the resources we've just created. Let's begin by exploring the file we generated with the configuration for the cluster. This is the configuration file for the cluster. The name of the file is central.context. Let's navigate to the Google Cloud Web Console and explore the cluster. To do that, we're going to navigate to the Compute section, select Kubernetes and Clusters. We're going to hide this panel. Let's click on the cluster. Under the Details pane, we can see information on the cluster. This is the version we selected. That's the endpoint of the API server. The cluster has 2 nodes. It was deployed in the US Central 1B zone. The cluster is making use of the default network. You can see the range of IP addresses that will be allocated to pods, as well as the range of IP addresses that will be allocated to services. We enabled workload identity. This is confirmation of workload identity being enabled. We also specified a label. At the bottom, we have the configuration of the pool. We're using the default pool. The version corresponds with the version of the master. The pool has 2 nodes. The machine type is N1 standard 4, and auto-scaling is enabled. Should you wish to explore the configuration of the nodes, you can do that from the Nodes tab, and then select any of the nodes. From the Summary tab, you can view dashboards for CPU, memory, and disk utilization. You can also see the configuration of pods running on the node, as well as resource summary configuration. Let's return to our Google Cloud Shell console. In step number 4, we're going to create the remote cluster. You may recall that we previously installed a tool called kops. Kops is the utility we're going to use to install the remote cluster within Compute Engine virtual machines. To get started using kops, we're going to enable Google Compute Engine support by setting this environment variable. Next, we're going to create a cloud storage bucket where our state configuration files will be stored. The fully qualified domain name of the cluster will be remote.k8s.local. The cluster will be created using virtual machines in the US Central 1B zone. We're going to store configuration information on the cluster in the cloud storage bucket we created earlier. The cluster will be configured with 2 nodes. We're going to use the machine type N1 standard 4, and we're going to enable admin access from any location. Having created the cluster, we're going to store the configuration of the cluster in the file remote.context. Let's use the kops validate cluster command to ensure that the cluster is ready for use. The remote cluster is now available. Let's create a cluster role binding and assign the cluster role of cluster admin to the current logged in user. Let's switch context to the remote cluster. In the next step, we're going to register the remote cluster on the Google Cloud Platform using GKE Connect. Let's switch context to the remote cluster. Let's grant the current user that is logged in the role of GKE Hub admin. I am service account admin. I am service account key admin, and resource manager project I am admin. Next, let's create a service account, Anthos Connect, the service account we're going to use to register the remote cluster on the Google Cloud Console. Let's grant the role of GKE Hub Connect to this service account. Let's download the JSON key for the Anthos Connect service account. Using the JSON key we have just saved, let's run the gcloud container membership register command to register the remote cluster on the Google Cloud Console. While registering the remote cluster on the Google Cloud Console, we're going to grant access to the credentials of the remote cluster using the configuration file we created earlier, the remote.context configuration file. Let's create a service account for remote administration, remote admin service account. Let's grant the remote administration service account admin privileges on the remote cluster. Let's grab the remote cluster's configuration file for the admin username. And let's grab the configuration file for the admin password. Let's use the admin username and password to register the remote cluster on the Google Cloud Console. To do this, I'm going to copy the password and we're going to switch over to the Google Cloud Console to register the cluster. Let's go to the cluster's landing page. You can see here the remote cluster. The remote cluster is registered, but it's currently not connected. To connect the remote cluster, let's log in with the admin credentials. The username is admin. I'm going to paste the password I just copied. And now we have the remote cluster connected and visible from within the Google Cloud Console. Let's explore the remote cluster. Here we can see some basic information on the remote cluster. Let's click on nodes. You can see here the nodes for the remote cluster. There are 3 nodes in total. There are 3 virtual machines in total. One of the virtual machine is the master and the other 2 are nodes. You can also see the CPU and memory utilization for each of the virtual machines. We can explore the virtual machines further by clicking on it. And here you've got additional information on the virtual machine. You can see the pods that are running on each virtual machine. You can also see a summary of the resource utilization. Additionally, you can switch to the Details tab to view the configuration of the node. You can also view the configuration as a YAML file, and you can access events on the Events tab. Let's return to the Cloud Shell console and carry on with the demo. In the next step, step number 6, we're going to configure remote cluster access. We're going to start by granting the role of Storage Object Viewer to the current user. In the next step, we're going to export the configuration of the remote cluster into the COPS Cloud Storage State bucket. Having done that, we're going to switch context to the remote cluster. We're then going to modify the firewall rules for the remote cluster, allowing access from any source IP. We're going to switch context to the central cluster. We're also going to update the firewall rules for the central cluster to allow access from any IP address. Let's navigate to the Google Cloud Web Console and explore the firewall rules configurations we've just made. To do that, we're going to navigate to the networking section, select VPC networks, and firewall rules. You can see here the firewall rules we've updated. This is one of the firewall rules. We specified the source as any IP, that's 0.0.0.0/0. We also modified this firewall rule. This is the firewall rule that allows SSH access to the master node, as well as the firewall rule that allows SSH access to the nodes of the cluster. Let's select one of the firewall rules to explore more closely. This is the firewall rule that allows external SSH access to the master node of the remote cluster. You can see here the protocol is TCP port 22, which is SSH. That's the target tag, the tag for the master node. The priority is 1000. The direction is ingress, that's incoming. We're allowing traffic. And the source IP range is 0.0.0.0/0, which essentially means any IP address. And you can see at the bottom the instances that this applies to. And the instance is the master, which is the virtual machine running the master for the remote cluster. Let's return to our Cloud Shell console. In the next step, we're going to install Istio, that is our service mesh, in the two clusters. Let's start by changing into the directory where Istio was extracted. Next, we're going to switch context to the central cluster. We're going to create a namespace for the Istio system components. Let's ensure that the Istio system namespace was created. I'm going to navigate to another tab. Let's change context to the central cluster. Let's retrieve the credentials of this cluster. Let's display the namespaces that have been configured. You can see that the Istio system namespace wasn't created, so let's go ahead and create the namespace before carrying on. Let's return to our demo. Let's apply the configuration file to create the service account for Tiller. Let's make sure Tiller is installed and running. Let's install Tiller. Let's make sure Tiller is installed. Let's create a generic Kubernetes secret with the credentials for the root certificate authority that will be necessary for mutual TLS configuration. Let's install the Istio custom resource definitions within the central cluster. Let's apply the kiali-secret.yaml file to configure the username and password for Kiali, which is admin and password. Next, let's install the multi-cluster gateway configuration for Istio within the central cluster. Having configured the central cluster, we're now going to switch context to the remote cluster. Let's create a namespace for the Istio component within the remote cluster. Next, we're going to apply the Helm service account YAML file to create a service account for Tiller. Having created the service account for Tiller, we're going to proceed and install Tiller within the remote cluster. Next, we're going to create a generic secret using the credentials for the root certificate authority, which are required for mutual TLS configuration. We're now going to use Helm to configure the custom resource definitions for Istio. Next, we're going to create a Kubernetes secret by applying the kiali-secret.yaml file in order to configure the credentials for accessing Kiali. Let's configure the multi-cluster gateway configuration for Istio by applying the value Istio multi-cluster gateway YAML file on the remote cluster. Before we carry on to the next step, let's return to our Google Cloud Web Console. You can see at the top we have the option for deploy. Let's specify an existing image. Let's hit continue. You can see here that with GKE Connect configured, we have the ability to deploy from within the Google Cloud Console to an external cluster. We can click deploy. Here we have the Nginx application being deployed to the remote cluster. Let's navigate to the Workloads tab. Let's sort by cluster. And here you can see the Nginx deployment. I'm going to delete this deployment. Let's return to our Google Cloud Shell console. In the next step, we're going to enable Anthos Service Mesh on the cluster running on the Google Cloud Platform. Let's switch context to the cluster running on the Google Cloud Platform. Let's enable the Anthos Service Mesh specific APIs. Let's download and apply a customized version of the Anthos Service Mesh YAML file against the central cluster. In the next few steps, we're going to create a number of service accounts. The first service account is the Istio Mixer service account. Let's grant the role of context graph asserter to the Istio Mixer service account. We're also going to grant the role of logging log writer to the Istio Mixer service account. And also the role of monitoring metric writer. We're also going to grant the role of IAM workload identity user to the Istio Mixer service account. Next, we're going to add an annotation to the Istio Mixer service account. Before moving on to the next step, let's return to our Google Cloud Web Console and explore the service accounts we've just configured. To do that, we're going to navigate to I am and admin. Let's select service accounts. Here you can see a service account we created earlier, the Anthos Connect service account for connecting the remote cluster to the console. The service account we created more recently was the Istio Mixer service account. Let's navigate to I am. This is the Istio Mixer service account. You can see the roles that we configured against this service account. Let's return to our Cloud Shell console and move on to the next step. In the next step, we're going to configure Istio DNS. This configuration enables service discovery across cluster boundaries. Let's switch to the central cluster, that's the GKE cluster. Let's apply the configuration file for the GKE cluster. The configuration file is a config map object. The name is kube-dns. In the configuration, we're setting the value for global as the IP address of the core DNS service that is running within the central cluster. Let's apply this configuration. Next, we're going to switch context to the remote cluster. We're going to also create a config map configuration on the remote cluster, and we're going to set the value for global to be the IP address of the core DNS service that is running within the remote cluster. Let's return to our Google Cloud Console and explore the configuration we've just performed. To do this, we're going to navigate to our Kubernetes Engine cluster. Let's have a look at services and ingress. Let's scroll down to our core DNS service. Here you can see two core DNS services. The core DNS service in the central cluster has an IP address of 10.107.8.48. Let's navigate to the configuration tab and view the configuration for the config map. We're going to enable access to system level configuration, and we're going to filter by namespace and select the kube system namespace, and type, we're going to filter and select just config maps. You can see here the two kubedns config maps for the central and remote cluster. Let's have a look at the configuration for the central cluster, and you can see here the IP address. Let's take a look at the configuration for the remote cluster. This IP corresponds to the IP of the core DNS service in the remote cluster. The kubedns service in each of the clusters will use this configuration in order to forward service discovery requests for services running outside of the cluster to the core DNS service running locally within the cluster. Let's return to our Cloud Shell console and continue with the demo. Having configured DNS, we're now in a position to deploy our application. We're going to select option 10. Before deploying our application, we're going to save the gateway IP address of the cluster running on the Google Cloud Platform into an environment variable. We're also going to save the IP address, that is the gateway IP address for the cluster, the remote cluster, into an environment variable gateway IP underscore remote underscore cluster. Next, we're going to switch context to the central cluster. That's the GKE cluster. We're going to customize the service entry YAML file for services that are remote to the central cluster to include the IP address of the gateway of the remote cluster. Let's apply this configuration. Let's create a namespace for the applications that will be deployed into the central cluster. Let's label this namespace for automatic Istio sidecar injection. Let's proceed and deploy the microservices into this namespace. We're going to switch context to the remote cluster. We're going to customize the service entry YAML file for the remote cluster such that the configuration references the gateway IP address of the central cluster for services that are running outside of the remote cluster. Let's create a namespace for the services that will be deployed into the remote cluster. Let's label the namespace for automatic Istio sidecar injection. Let's deploy the microservices into the remote cluster by applying the YAML files in the remote subdirectory. While waiting for the microservices to initialize, why don't we take a look at the configuration files which we've applied in order to deploy the application. I'm going to navigate to the Cloud Shell console. In the Cloud Shell console, we have a number of folders. I'm going to start with the central folder. In the central folder, we have a YAML file for deployments. This is the configuration for all the microservices that will be deployed into the central folder. Additionally, we have a YAML file for Istio defaults. This has the configuration for the gateway, virtual service. The front-end service is running within the central cluster. And here you can see the gateway configuration for that service. The protocol is HTTP. Port is 80. The DNS is star, which means we can access this service using just the IP address. We also have a virtual service configuration that specifies the URL path to the service, the IP address. We also have a service entries YAML file. In this service entries YAML file, we have the configuration for all of the services that are not running in the central cluster. We also have here a configuration file for all the services relating to the microservices that are deployed within the central cluster. We also have a subfolder, Istio-multicluster. This is the subfolder that contains the configuration file we applied in order to create the secret for Kiali. Also included in this directory is the Istio multi-cluster gateway configuration file. Let's return to the Google Web Console and explore the microservices we've just deployed. To do this, we're going to navigate to the Workloads tab. And here you can see all of the workloads running. There is currently an authentication issue with the email service. Click on the email service and have a look at the log file for the pod. Let's view logs. You can see here that the error relates to a permission denied 403. Request had insufficient authentication scopes. So let's navigate to services and ingress. In order to access this application, we need to click on the IP address of the ingress gateway for the central cluster. The front-end service is running within the central cluster. So let's click on the IP address. And here we have our Hipster Shop application. Let's purchase some items. We're going to buy a mug. And let's add to cart. And we're also going to buy terrarium. Let's place our orders. And you can see that everything is working just fine. Let's return to our Cloud Shell console. In order to fully explore Anthos Service Mesh, we're going to migrate all of the microservices currently deployed in the remote cluster to the cluster running on the Google Cloud Platform. Let's select option 11 in order to perform the migration. Let's switch context to the central cluster, that's the GKE cluster. Let's apply the YAML file for the configuration of the microservices currently running on the remote cluster on the central cluster. We now have all of the services running across the two clusters. Let's delete the service entry YAML file configured within the central cluster in order to prevent access to the services running in the remote cluster. Let's navigate to the Google Cloud Web Console and configure some Anthos Service Mesh service level indicators and service level objectives. To do this, we're going to select Services under the Anthos section. Here you can see all of the services running on the Google Cloud Platform. We're going to select each of these services and configure some SLOs and SLIs. So let's start with the SLI service level indicator. Let's specify availability. Our compliance goal is 95%, or let's just say 99% availability, rolling period of 1 day. Let's submit this. Let's create another one. Latency, let's say 100 milliseconds. Let's make this 98%, rolling period 1 day. Let's submit. I'm going to repeat this for all of the services, and we're going to allow a few minutes and return and explore the outcome. Let's explore the Anthos Service Mesh capabilities. To do that, we're going to navigate to Services under the Anthos section. You can see the dashboard here. On the dashboard, we have high-level information for all of our services, requests per second, error rate, and latency. We also have an indication of the number of alerts that have been defined and fired. We have a warning that we're out of error budget for 3 of our services. Let's select one of these services in order to drill down a little bit further. On the left, you can see the various tabs that are available. Let's start with the Overview tab. Overview tab is very similar to the dashboard. Here we have some high-level information on the request. We can show a timeline and filter or zoom in to specific time frames. Let's have a look at health. On the Health tab, we have high-level information on how well we're doing against our target from a compliance perspective. Under the Metrics tab, we have a number of dashboards. We have one for requests per second, error rate, latency. We can customize these dashboards. For example, we can select requests per second based on error code. We can also select a timeline. Let's explore the Connected Services tab. So in terms of inbound, there is no inbound microservice that's connected to the front-end microservice. Let's look at the outbound. From an outbound perspective, the front-end microservice connects to all of these microservices. You can see the ports and some metrics. Let's explore the Diagnostics tab. Here we can see the errors that are being generated, and we can drill down on the specific errors here. A lot of the errors we're experiencing have to do with authentication. Let's have a look at the Infrastructure tab. Under the Infrastructure tab, we can view requests per second, CPU, memory, and disk utilization for the microservice. We can also access the pod within which the container is running. We also have some high-level metrics displayed here. Let's have a look at security. Under the Security tab, we can see the request port. The source principal isn't known because mutual TLS isn't enabled. This is the namespace where the workload is deployed. Under the Security tab, we can see the microservices accessing the front-end microservice. Hope you enjoyed watching this video. Have a nice day.